Hi everyone. Today I'm going to present our work entitled A Tool for Spatially Based Prediction of Consumer Lawsuits Against Electric Power Companies. So I'll first start by introducing some context. The main purpose of an energy company is to provide electricity services to the final consumer. In Brazil, we have Equatorial Energy Group, which is responsible for electricity distribution in 4 states in Brazil and has over 5 million customers. So one of the main things that a company this big has to consider is the customer dissatisfaction and the quality of service, because the customer dissatisfaction translates to lawsuits, and lawsuits translates to loss of money. So in fact, millions of dollars are spent on lawsuits yearly. So the main causes of lawsuits are the poor quality of services, power interruption, and equipment maintenance. So the motivation of our work is to create a tool that could preemptively identify customer dissatisfaction and its reasons. And with that, companies can create action plans to avoid lawsuits. So the purpose of our work is to construct an intelligent method to identify clients that may be related to unregistered power consumption using the customer's history. So in this work, we explored two classifiers, the extreme gradient boosting and balanced bagging classifier. We also want to provide a tool for spatial visualization and analysis of lawsuit predictions. So the proposed method consists of 5 steps. The first step is the data acquisition. Then we have feature extraction, followed by training and prediction, and finally, spatial analysis and visualization. So the first step of our method is data acquisition, and which was performed on a private dataset from Equatorial Energy Group in the state of Maranhão. So this dataset contains historical data acquired by several sectors of the company, which consists of consumption history, power supply discontinuity information, financial information, and customer complaints, and also equipment information. The second step of our method is the feature extraction. So the features are extracted from lawsuits and customer history. So basically, the feature contains general information such as spatial location, neighborhood, and the type of client, which could be either commercial or residential. We also extract information of power consumption, power loss, invoice information, financial history, and lawsuit history. So during feature extraction, we also perform a transformation and encoding step. So this transformation consists of a normalization of data, and we encode the categorical variables using one-hot encoding. We also generate some features. So by creating some time intervals. So we create an interval that contains the last 3 months. Then we create another interval which contains information from the last 18 months. And we also consider as the third time interval the all-time period. So we generate statistics over these 3 time intervals. And the statistics are the counter, mean, standard deviation, kurtosis, and skew. For training, we used 2 classifiers, extreme gradient boosting and balanced bagging classifier. So now we're going to present the results of our method. So initially, we show the proportion of clients with unregistered consumption in our data set. So we have a total of over 2.4 million clients, and only 14,000 are clients with unregistered power consumption. So we can see that it is a very unbalanced data set, and we separated 10% of this data set for validation, and we chose balanced bagging as our classifier because it achieved the best results in this validation set. So here we present the results that we achieved in this subject of UPC, unregistered power consumption. We can see that it was achieved over 91% of accuracy, over 96% of sensitivity, and over 91% of specificity using the balanced bagging classifier. Now we present our spatial analysis and visualization tool. So we have a web interface which contains a filter region in which the user can choose, can filter data and choose some specific subject or region or city. We also have a region for showing the best features or the most important features in these predictions. So if the user click in one of these clients, the tool is going to show the information for that specific client. It's going to show the identification number, it's going to show the probability of a lawsuit, and it's going to show a bar chart with the most important features for that prediction. So in conclusion, our method has achieved promising results, which were achieved with our random division in a random train test division in the UPC subject. And we observed that the geographic location is the most dominant feature in this subject. Some other factors such as consumption history, the type of service, invoices issued to the consumer, and the number of previously issued UPC invoices are also very important in this subject. So as for future work, we plan to study new lawsuit subjects, not only UPC. We want to explore more classifiers in the training and prediction step. And we also want to generate other forms of data visualization, such as heat maps. So I thank you everyone for your attention. That's it for today.